So in this one, another practice problem, and the intent, the hope is that the more and more we do practice, you will keep on getting better and better, and that's what I want you guys to do. But that's what I want. That's what I want you guys to become. I want you guys to become really, really expert in this idea of writing, reading, comprehending mathematical statements, and using predicates, quantifiers, and logic connectors. Okay, so the question here is, every student in this class has been in at least one room of every building on campus. So we are going to first figure out how many domains are we playing with. So the keywords here, that should somehow trigger things out. That should help you. Every student in this class has been in at least one room. Okay, I'm just trying to get these quantifiers. This tells you this tells I'm looking every for every single item in this orange domain. Here I'm looking for some entity in this pink domain, and here I'm looking for every. I'm using orange already. Let me use purple. Every building. So I've got three colors. I've got three universes. My third universe over here. Let's start everything from the right here. Is the universe of buildings. Then I've got my universe in pink. I think I've got two pinks over here. This is, I don't know, I'm kind of colorblind, so, well, they're definitely different colors here. So this is the universe of rooms, and then I've got universe of students. Okay, here's my universe of students. Okay, so every student, meaning everybody in this orange domain, everybody in this orange domain. Okay, everybody over here, everybody in this orange domain has been in at least one room. Okay, there's at least one room over here of every building on campus. Okay, so again, in the pink domain, we're looking at every single building. Okay, so at least one room, which implies that once I've selected a building, there could be one room in that building where every student in that class may have visited. Okay, so how am I going to put the statement mathematically? Now, I definitely need some predicates over here. So I'm going to again define my predicate P, and my predicate P is going to be, in this case, let's say it's a predicate of two variables. So P of z comma y implies that z is in y, and my predicate Q of x comma z is a predicate that implies that x has been in z. Okay, so now what I'm going to do is I'm going to say for all x's, okay, everybody in this orange domain, and for all y, for every building, there exists some room such that P of x comma, in this case P of z comma y, and Q of x comma z must hold. Okay, so I go across every single student, and I must go across every single building, and as I keep on doing that, there must be some z, okay, there must be some z that I can pull from this domain such that this predicate must be true. Okay, so let's think about this. I'm going to first select for some x's. So let's say I'm going to select my first student over here, and well, I'm a student. Let's assume I'm a student right now. So let's say I'm a student right now, and I'm going to select Abbas over here. And for some y, so let's say this is my CAS building, and I'm going to select some z, and Well, this Z could be, let's say, this could be CS. Let's say this is my office here, which is PSY 230. Okay. So if I'm saying, if I've selected some X, some Y, and I'm selecting some Z, let's see if this piece over here holds here. And again, just to make things clear, everything over here in purple, everything here in purple must be true for at least one Z. So once I plug these values in, it's obvious that the predicate P of Z comma Y does not hold because this says Z is in Y. Well, Z over here is Psych 230. Well, Psych 230 is not in the CAS building. This entire thing becomes false. Well, if this becomes false, this entire piece is false as well. So I need to find a different Z, right? And I need to find a different Z over here, and the only Z that's going to make it true is that Z which happens to be in the CAS building, right? So if I keep on going across the entire universe, right, at some point I need to come down to that quotient over here, which happens to be all those rooms that are in the CAS building. So let's select one such room in the CS building. I don't know, let's select 148. Okay, or let's just take 522, which is our lecture hall. So once I select 522, well, is 522 in the CS building? Well, this predicate P becomes true. And Q of X comma Z, well, has Abbas been in 522? Well, this becomes true as well. So true and true, which makes it entire true. So I did find one such Z, which means this is true. I found that one Z over here. But keep in mind, I just wanted this one Z for Abbas and the CS building. But I need to do this. I need to do this for every single X's. I need to do this for every single Y. Right? So I'm going to traverse the entire universe of X's. I'm going to traverse the entire universe of all these buildings over here. And as I keep on doing this, right, I need to keep on finding such Z's which makes this entire predicate true, which will imply that every student in this class has been in at least one room of every building on campus.